There's always one in every class. Okay. So 2-3, this is curve sketching. Okay, so now this can be super easy or it can be super complicated. Okay, so this textbook breaks this down into steps to hopefully make it easier. Okay, sometimes the functions are incredibly complicated and may require the use of a calculator, but the goal of this section is to be able to graph functions without using a calculator. Okay. Now, eventually we'll get into more calculus stuff that helps you find more details, but this is kind of like the intro to that piece. Okay. All right. So, if you read through this stuff, I'm not going to go over every single thing that this says, but I don't know if you want to highlight the same things that they highlight or underline that in your book. Okay. You remember that the domain is all the x values. Hopefully that's not new information.
What?
The domain is all the x values. Okay. How do you find vertical asymptotes? Okay, so anything that makes the denominator 0 and that does not cancel out with the top. Okay, so I'll explain that more. The part where things cancel, what causes, or what is that, how does that affect the graph? Okay, non-removable, which are literally holes. Okay, so holes, that's again coming from the denominator restriction. If you simplify it and it cancels with the top, that's where you see a hole. We can find exactly where holes are. Notice that it says in parentheses. Okay, we can find the holes, like exactly the ordered pairs, by plugging the x value into the reduced function. Okay, so we'll practice that so you know what that means, because that will be helpful. Okay, you know how to find x and y-intercepts. That shouldn't be new information, right? I'll take that as a yes. Okay, end behavior. Do you guys know what I'm talking about when we say end behavior?
The highest degree of the term.
Okay, so it comes from the highest degree of the term, but do you know what it literally means?
Like what is the exponent?
Yeah, so like basically if you look at the very ends, as x approaches infinity and x approaches negative infinity, what are the two ends of the function doing? Are they going up to infinity like a parabola would do? Or if it was a John Travolta, you'd have one going up to infinity and one going down, right? Okay. We're also going to talk about even and odd vertical asymptotes. We're going to talk about even and odd X-intercepts because that also gives you information about the way the graph looks. So, you guys ready? I'll take that as a yes. Okay. All right, so for this one it says give the domain, reduce the function, and then find vertical asymptotes, holes, and end behavior. So we're not actually sketching the graph in this one. We're just finding all of the stuff that kind of gets you there. Okay, so for number 1, what is the domain and how would I figure that out? Okay, so good. So remember for the domain, there's 2 ways in which you can restrict the domain. What are the only 2 ways to restrict domain? So you can't have 0 in the denominator. What's the other one? And you can't have a squared in or a negative square root, or 4th root, or 6th root, or any kind of even-powered root. Okay, so this one has a scenario where you have x's in the bottom. Okay, so I'm going to go straight to simplifying the bottom. Can we factor that? So pull an x, right? X minus 2. Okay, so that will immediately show me the 2 values that x cannot be. What are my 2 restrictions?
0 and 2.
0 and 2, good. So x cannot be 0 or 2. Okay, do I have a vertical asymptote? And how would I even know? Okay, anything that makes the bottom 0 but does not cancel with the top. Okay, so do you notice anything that does cancel? No. Okay, so if nothing cancels, then I have no holes, so what's left have? Vertical asymptotes. Okay, so I have two vertical asymptotes. What are my two vertical asymptotes? They come from the restrictions. 0, 2, okay, good, yeah. Vertical, yeah, oh yeah. So we have vertical asymptotes and they're at x equals 0 and 2. Okay, now before I go on, I want you to notice that not only identifying the vertical asymptotes, but also identifying if they're even. So remember how they split apart and went like this, versus the even scenario where they both go up or they both go down. Okay, so are these even asymptotes or odd asymptotes? How do I even know? What am I looking at? Okay, so I'm looking at the quantity for each of the exponents. So you see how there's an x? What's the invisible exponent up there? It's a 1, yeah. 1. So is 1 an odd number or an even number? Odd. Okay, so 0 has an odd asymptote. What's the invisible asymptote on the x minus 2? 1. So what kind of asymptotes are both of these? Odd. They are both odd asymptotes. Okay, that tells us that the graph splits apart at those two places. Okay, end behavior. How do I decide end behavior? What is that going to come from? Let me write down 2 letters. Horizontal asymptotes. Okay, so do we have horizontal asymptotes in this one? And how do I know? Okay, it's a rational equation. Everybody know what we mean by rational? Fraction, right? Okay, so if we have a fraction, is it bigger on the top? Is it bigger on the bottom? Or is it the same? Bigger on the bottom, right? You got x over x squared. So where's my horizontal asymptote? At 0. If it's bigger on bottom, it always goes to 0. So I have a horizontal asymptote at y equals 0. So that's going to tell me my end behavior on both ends. Okay, so the end behavior, you have to tell me the right end and the left end. Okay, so you can abbreviate that. We can say right end and left end. Okay, so anytime you have one horizontal asymptote, both ends are going to go to that value. Okay, so where's my right end going? Let me say that statement just before that I just said. If we have horizontal asymptotes, both ends are going to go to that horizontal asymptote. Where's my right end going? 0. Where's my left end going? 0. Okay, so they always go to that asymptote. Good there?
Wait, so the end behavior, you always just put the right and the left?
Yep,
So
you have to have
you
right and
include
left.
the horizontal asymptote, so it just make it easier.
Right. Because okay, so if I just had a simple function like x squared, okay, what does an x squared function look like? Parabola, right? Okay, so where would my two ends be going? So my right end is going to infinity, my left end is going to infinity. Okay, so we can use the exponents to see what that is. So if it was like 29x cubed plus, who freaking cares? We got x cubed, so we know right end is going up, left end is going down. Okay, it gets a little more complicated when we have rational equations, and that's why they use this as an example. Does that kind of make sense? Okay, I'm going to switch colors, so then, can you guys see it all right if I just have it this big? Or do I need to go back in? Okay. Okay, number 2. What's the domain of number 2? Okay, yeah-ish. So what's the value that x cannot be? Cannot be, right. There you go. Can't be. So you want to say, if you just wrote -3, that would mean only -3 exists on the function, which would be a single point. There's only one value that makes the denominator 0, right? Okay, so vertical asymptote at -3. Okay, it does not cancel with the top, so there is no hole. It is a vertical asymptote. We have one at x equals -3. And what kind of vertical asymptote? Is it even or odd? Even, right? Everybody looking at that too? Whoa.
Wait, can you sketch that last graph?
Can we? Can we not yet? We're gonna get there.
Okay.
But we'll do lots of practice. We're just kind of going slow just to identify the pieces. So in behavior, do I have a horizontal asymptote?
Yes.
Okay, so this is a scenario where you have a slant, right? Okay, so if we have a slant asymptote, I need to decide what kind of slant it is. Is it going to be a slant like this, where my right end is going up to infinity and my left end is going down, or vice versa? How am I going to tell? Kind of, it would be like an hourglass that kind of like goes up. Like, it would kind of look like this. Like if you had this, there could exist this like slant asymptote like this. Kind of see? That's probably what, I don't know exactly what this one looks like, but something along that. Actually, this is an even asymptote, so it wouldn't look like that. It would look like, let's not graph it. Okay, so how do I decide if it's going to positive infinity or negative infinity?
You just guessed. Yeah.
Yeah, right? You got to put in like a big number and see what would happen. Okay, and remember you only have to do the first term on the top and the first term on the bottom. Sam, you okay? Hey. You right? You're okay. Okay, on the top, if I put a big giant positive number, would it be positive or negative? If I put a big giant positive number into the top, would it come out positive or negative? Positive. If I put a big giant number into the bottom, I would get positive. So, is the right end going to positive infinity or negative infinity? Positive, good. Okay, and I can check the left end, but I know there's a slant, right? So probably the left end's going, not probably, it's going down, right? To negative infinity. I could double check it though by plugging in a negative giant number. Because it's a case where it's bigger on top,
Okay.
so it's a slant. Okay, ready for 3? Okay, so do you notice right away, what did they do with number 3? They factored it, which was very nice of them. So before I cancel anything out, I want to state my domain restrictions. What are my 2 domain restrictions?
2 and negative.
Yeah, perfect. X cannot be 2 or negative 2. Okay, so now if I was going to reduce, see this little red right there? That's standing for the reduced version. So what would reduce? Yeah. Okay, so from then on, I'm basically using the reduce function to kind of figure out the rest of this. Okay, so vertical asymptote. Is there a vertical asymptote? X equals, good. And is it an even or odd vertical asymptote? Odd, excellent. Everybody okay with that? Okay, hole.
Yeah.
Where?
Negative
Close. Positive 2, right? So 2 came from what we canceled out. Okay, so we have a hole at the x value 2, but we can find its corresponding y value. Okay, so all I have to do to find the corresponding y value is plug it into my reduced function, and I can find it. So I can go 2 plus 2 over 2 plus, whoops, I said that wrong, 2 plus 4 over 2 plus 2, so 6 over 4. So anybody else notice that that's 3 halves? Okay, so that's exactly where that hole would lie. Okay? End behavior. Is it bigger on the top, bigger on the bottom? Go back to the original to look.
It's
Or the same. Yeah, same. So I have a horizontal asymptote where y equals 1. Is that what you guys all said?
Yep.
Right? Okay, so that means both my ends, I can say, right? Okay, so remember how from up here,
Oh, yeah.
we're looking at, so the coefficient in front of those is 1 over 1.
Could you just use the reduce?
No, you have to go back. Good question, though. Even though I think it'll give you the same values.
Yeah.
Unless you canceled out like a number in front. Yeah, go back to the original. Let's say that. So left and right are both going to go to 1. How are we doing? Good? Hanging in there? Gosh. Okay, so here we go. So this is just a little recipe that potentially can help you graph functions. Okay, ones that are complicated, of course. Okay, so first it helps to find the domain. Then find the reduced version, state asymptotes, find your intercepts, check your end behavior. You can check for symmetry. I probably won't ever do that. You can find a starting point by plugging in x's and coming up with y's, and then just graphing those points. Okay, you guys ready? Okay, here we go. Okay, so now before I even start this, I'm going to look at this and say, what does this look like? Okay, what is the parent function that this is going to look like? Okay, so if I was going to put this in the standard form, what would the very first term be? Number 4. If I was going to put this into standard form, what would this look like? If I was going to FOIL it and put it into standard form, what would the first term be?
X to the 4.
There it is. Whew, that was hard. Okay, so x to the 4th. Okay, so x to the 4th tells me what this function looks like. What is anything to the 4th power going to look like? Parabolic, right? Okay, so it could potentially have some more wiggling. Okay, it could have 4 zeros, potentially. So it could look like a W. But the end behavior is both going up, right? Okay. Okay. Do I have a domain restriction on any kind of parabola or W? No, there's no dividing by 0 anywhere. There's no square roots, so I can say all reals. Okay, so you can write that out, all reals, or you can say negative infinity, or you can use the fancy little math symbol. Okay. X-intercepts. How do you find the X-intercepts? Okay, yeah, so we technically set the y equal to 0. This is in factored form. We say awesome, and we can easily say that we've got, 0, 1, and negative 2. Okay, what?
The x plus 2 squared isn't.
Okay, let's talk about it. Yes, it absolutely matters. Okay, so I am also going to label X-intercepts as even and odd as well. Okay, because if you have odd intercepts, the function will cross through the x-axis. If you have an even intercept, does anybody know what it does? It bounces. Okay, so I don't know if you want to write that down somewhere. Odd x-intercepts cross through the x-axis. Even intercepts bounce. They bounce off of the x-axis. Okay, so of 0, 1, and negative 2, what is 0? Is that even or odd? Okay, what's the exponent above this x right here? 1, so is that even or odd? What about the x minus 1? Odd. And what about the x minus 2?
Odd.
Even, right? Okay, so these two, 0 and 1, are both odd. Okay, so that tells me that those are going to cross through the x-axis. -2 is even. So when the graph hits -2, it's going to bounce. Boink. Go back, right back up, or go back down. Okay, how do I find the y-intercepts? Plug 0 into the x's. We could probably do that one mentally because it's in factored form. If I plug 0 into the x's, what's my y-intercepts?
2 squares for -3.
How about 0 times who cares?
No.
So 0?
Yeah.
Yeah. Okay, remember you can only have one y-intercept, right? Otherwise it technically is no longer a function. Okay, end behavior, we talked about this. This looks like a parabola. So I can say right end and left end are both going to infinity. All right, you guys ready? Here's the graph of this. I'm going to make this a little smaller. Okay, so I'm going to start by plotting things that I know. I know my intercepts. Okay, so I can plot my y-intercept at 0, my x-intercept, which is also 0, 1, and -2. Okay, so can you visualize what's going to happen here? Remember, I have this parabolic shape. Okay, so my two ends are up.
I can see it.
Okay, and what's going to happen when I get to -2? It's going to bounce, and then when it hits 0, it's going to cross and go below,
Coming up.
and then it's going to come back up and cross through at 1.
How do we know how far down?
Good question. How do you know how far down it goes? That's when you start getting into calculus.
Oh.
Okay, so in this lesson, we don't care how far up and how far down it goes. Eventually, we're going to get there, and you'll be able to figure out those mins and maxes. Okay. Everybody okay with that one?
Yeah.
Pretty easy? Okay. Okay, here we go, number 5. Now this one looks awesome.
Oh.
Okay, you guys ready?
26.
Woo! Okay. Domain restrictions. X cannot be what? 0, 1, 3. Anything else? Good. Okay, now if I was going to take that function and reduce it, what kind of things would cancel? One of them, right? So the one on the bottom would go away, and I would get rid of the squared on top.
You can do the same thing with the x squared.
Yeah. So I get rid of the x on the top and then the square on the bottom. Right?
That's it, right?
That's it, yep. Okay. All right, so my reduced version of this become, x minus 1, x plus 3 cubed, x squared. Everybody good there?
Yep.
Okay. So now I can find my vertical asymptotes from my reduced version. 0 and 3, good. And I'm going to be a little more tedious when I write this. 0, what kind of asymptote is this? Even or odd? And then 3 is even. I don't know how, I didn't write that nicely. There we go.
The whole is just the word asymptotes.
Okay. All right, so holes. Now holes come from anything that I canceled out. And technically, how many things did I cancel?
X is 1. So 1.
There's 2 things, right? So I canceled a 0. Okay, so what did you just notice? Okay, so is it a hole or is it a vertical asymptote?
Oh.
How? How can you have a hole in a vertical asymptote? Okay, so here's a rule. Vertical asymptote, no, let me say that again. Vertical asymptote, yeah, that's where I was going. Vertical asymptotes are going to trump holes. Okay, so if there's a vertical asymptote there, then it can't be a hole. So there's not one at 0. Trumps. That is not any kind of political statement. Don't even go there. Okay, where's my actual hole? What x value? X equals 1. There we go. Okay, now how do I find the corresponding value for that? Plug it in. And this one we can probably do mentally, I hope. Because on the first quantity on the top, we get 1 minus 1.
That is, yeah.
0. So the hole is on 0. 1, 0. Are you good there? Okay, is that an even or odd hole, by the way? Like, is it going to look like it crosses through? So you're looking here. What's the exponent there? Odd. Okay, so that tells us.
Wait, you don't plug in 1 for all of those x's?
Well, you do. Yes, you do. But if I have 0 here,
Make everything 0.
yeah, 0 times anything, and you'll have 0 over something else, which still is 0. Okay, so again, that hole is important because we know that it's going to cross, and it's an X-intercept spot. Okay, or yeah, okay. So the X-intercepts. What are my X-intercepts? So you're using reduce now.
0. Or do not have this.
Yeah, right. So the reduced version. So 1 and negative 3, right? So looking at the top,
Oh, X-intercept you get from the top.
yeah. Because to find an X-intercept, you set the y equal to 0, right? And if you have a bottom and you're set equal to y, your first step would be to multiply the bottom to the other side, and your whole bottom just goes away. So you just set the top equal to 0. Okay. Are they even or odd intercepts? Both odd, yeah, so they cross. Y-intercept. Set the x is equal to 0. Ooh.
0.
Yeah, no. But you kind of are close. There's a problem with 0. It would be 0 if there wasn't this vertical asymptote there. So if there's a vertical asymptote at the at the y-axis, there is none, right? It doesn't cross. Okay, end behavior. So, end behavior, we're using, we go back to the original, okay, and we're thinking about the standard form of what that would look like. Okay, so what would my exponent on the top be of the original? So I have x to the third, x squared, so that's x to the fifth plus 1 more, and x to the sixth. On the bottom I have x squared, and x, so x to the fifth. Everybody agree with that? So what does that tell me? Yeah, bigger on top, which means I have a slant. Slant, yep. Okay, so using this, I can use this. If I plug a giant number into the top, giant number into the bottom, is it going to be a positive or a positive? Or, yeah, okay. Okay, so my right end is going to go to positive infinity. If I plug a giant negative number into the top and the bottom, where's my left end going to? Good. Okay, ready for the hard part? Graphing it. Okay, so, yeah?
Y-Intercepts, could you also get 3?
Wait, say it louder.
X-Intercepts, could you also get 3 from the denominator?
No. Those are only vertical asymptotes.
Okay.
Denominators for vertical asymptotes. Okay, so I'm going to start by plotting intercepts and asymptotes. Okay, all right, so we have a vertical asymptote at 0 and 3. Okay, so I'm going to draw dotted lines to represent vertical asymptotes. Sorry, those aren't super straight. Okay, I know there's this positive slant asymptote, but I don't know exactly like how high or how low it is. It actually is going to be right through the origin. And I'll show you guys how to do that tomorrow because we're almost out of time. Okay, plotting my intercepts. So I have one at 1 and one at -3. Okay, I have no Y-intercept. Okay.
Wait, but there's a hole at one, so is it still an X-intercept?
So, oh yeah, sorry, yeah, you're right. Okay, so hole, so what should I have drawn there instead of an actual point? Thank you, Ren, good catch, you're right.
Just like a circle.
A circle. Okay, so what I know is that it's going to look like the function crosses through that, but it's actually a hole. So I'm still using it as a point to use. Thank you, good catch. Okay, are you ready for this part? Okay, so let's talk about this this right end over here. Okay, so I know that because this function is going upwards, we know that this function is going positive infinity. We said that earlier. Okay, so what's going to happen is this function is going to ride this, and because it's bounded by these asymptotes, which means it can't cross it, okay, it's going to curl and go back up. Okay, so right here, sorry, it goes up like this. Okay, you can't cross slant in vertical asymptotes. Sorry, give me a second. Okay, now where is the function going to be on the other end of this? What kind of asymptote is 3? Even or odd? Even. So that means that if it's going up, both sides are going up. Okay? So this other side is going to come down from up at infinity, come down, and it's going to cross through 1 and go down. It has to cross through that point. So it kind of has this, okay, so, but it can cross in the middle of them. We'll get there, I know, sorry. Only if there's a point for which it can cross. So it kind of has like this, like John Travolta-y look. Sorry, that wasn't greatly drawn. Okay, and it goes down. Okay, because it's only the end behavior. I'll do it again, okay, I promise. Okay, so now on this other side, what kind of asymptote is 0? Odd. So where am I going to start on the other side of that asymptote? Okay, so if on this side it's going down, on the other side it has to start at the top. Remember how they go opposite? So this one's going to go down, it's going to cross through this point and then go down towards that asymptote. So it kind of does like this. Totally weird thing. Okay, so this is what I'm going to do. I'm going to give you a few problems, and then we're going to play all with this. Like, we only have 30 minutes of class tomorrow because it's an early release day. I think what I'm going to do is I'm going to split 2, 3 into 3 days. So I'm going to redo that. I'm going to give you the problems that are just that first part without the graphing. Yeah, 1 through 3. If you feel so inclined to start the first part of 4, that would be a good start for tomorrow.